Hi, everyone. I hope you've played your 18 rounds of the Monty Hall game with switching. A quick recap. So let's say that I think the car is behind door number 1. Monty Hall decides to open door number 3. He gives me a choice to either stay behind door number 1 or switch to door number 2. As for the strategy that I told you to use, we must switch to door number 2. In this case, I lose, and that registers a loss over here. Okay, let's try this all again. Let's repeat the switching strategy 18 times. This is going to be like the movie War Games, where it's all very fast. Let's see this. Huh, look at that. So I've won 56% of the time, and I've lost 44% of the time. Let's try it again. After now 36 rounds, hey, it looks like I've won 2/3 of the time. And guess what? According to probability, I'm supposed to win 2/3 of the time. If you switch, there's a 2 in 3 chance that you're going to win the car. Let's have our old friend Michael explain.
Decided not to switch, but mathematically, you should always switch. In fact, if you switch, you will win not half the time. It's not actually 50-50. If you switch, you will win 2/3 of the time. And if you don't switch, you only win 1/3 of the time. So you have a 66.6 repeating chance of winning if you switch. Why should that be? Why is it not 50-50? Well, it comes down to two extremely important facts about this problem. The first one is quite easy for us all to agree on. It's the fact that when you make your first choice, oh, by the way, I never actually showed you the result. You stuck with 1. And Hannah, just like I said, you should have switched. You shouldn't always switch. Let's be clear about that. I'm not telling you a strategy to always win. I'm just telling you the best strategy in the long term. So you chose to stick with 1, but there's poop behind 1. The money was behind 3. So there it is, $1 million to scale. So let's get back to these two important facts. The first is that when you first choose a door, the probability that you have chosen the money is 1 in 3. Okay, that's the chance that you'll be right. The money's behind 1 of 3 doors. You have a 1 in 3 chance of picking the door with money behind it right off the bat. That's pretty clear. But that also means that 2/3 of the time, you are choosing a door that does not have money behind it. More doors have poop behind them than have money behind them. The second and much more important fact is that the host knows which door the money is behind, and the host will never open a door that has money behind it. I believe most disagreements over the solution to the Monty Hall problem come from confusion over the rules of the game. So let's make them extremely clear. First, you pick a door. Next, the host opens one of the 2 doors you did not pick. And the door the host opens of those 2 will always be a door with a goat behind it. You are then asked if you would like to stick with your original choice or switch to the door that you didn't pick that the host also didn't open. This is why it feels like a 50-50. We know that the money is either behind the door you picked or the door that the host didn't open that you didn't pick. It's behind one of them because it's definitely not behind the one the host opened. The host only ever opens a door with a goat behind it. But surprisingly, to switch or not is not a 50-50 choice. Switching allows you to win 2 out of 3 times. If you chose a door, like Hannah did, door number 1, say, and then the host flipped a coin and randomly opened one, sometimes the host would open a door that had the money behind it. And that would be terrible television because the money would be revealed and the host would say, okay, well, you were wrong. Would you like to switch to the one door that remains closed? Of course you wouldn't. It wouldn't matter. The game would be over and it would be boring. Instead, the host always opens a door of the 2 you haven't chosen that has poop behind it. Okay, or a goat, depending on which version you want to go with. So what does that mean? Well, it means that sometimes you choose the door that the money is behind. That's awesome. And in that case, it doesn't matter which door the host opens. The host could have a rule where they always open the, leftmost door, or maybe they just flip a coin and open one or two. Either way, the host can open either door. But most of the time, you didn't pick the door the money is behind. 2/3 of the time, you pick incorrectly. In that case, the host is forced to open one door. The host has no choice. The host cannot open 3 because the money's behind that door. The host must open the other door to reveal the poop. This is why you actually have more information than you might think. The host is always avoiding the door with the money behind it.
Let's have another interesting perspective from this video over here.
Doors, but we imagine having 100 doors. And let's imagine that we're playing the same kind of game. We have Monty over here. He is going to give you an opportunity to pick a door, and your dream flashcards behind one of these 100 doors, but there are 99 zonks all behind the other doors. Now, what is it that you're going to do? Well, you're going to pick a door. Say again, you pick door number 1. Now you're feeling a little bit different than you might have felt in the case where there were 3 doors, because there you thought, wow, I've got a 1 in 3 chance. Here you're thinking, I've got a 1 in 100 chance. I'm not going to get that car. It's not behind door number 1. It's probably behind one of the other 99 doors. What Monty does is he opens 98 of those 99 doors. He shows you 98 zonks, and he asks you, now, do you want to switch? Well, maybe just because of the sheer numbers, this thing is a little clearer. You know that there was 99 out of 100 chance that the car was over here, and now the only door you're left with after Monty shows you all those zonks is door, say, number 37, and you're thinking, this is no good, this is no good, all those doors are no good. Do I want to stay with 1 or do I want to stay with 37? You can sort of almost feel the concentration of that 99% going behind door number 37, and so you switch over here, and very likely you're going to get that car.
An interesting video from Number File over here. So a 2 in 3 chance of winning if you switch. By the way, this problem was famously featured in the film 21, Kevin Spacey there, explaining the Monty Hall problem. So it's a very famous problem. Now, what does this all have to do with today's lesson? We'll see in the next video.